Well, I'd like to tell you a little bit about some of the work that we have been doing here at UNC with snakes and snake venoms over the last 10 or 12 years, but I'm going to focus primarily on some of the work that we've done more recently, which was funded by the Colorado Bioscience Association, and I'd like to thank them for that. This has been very helpful for us in moving into some very interesting directions. What I'm going to do today is talk a little bit about venomous snakes, show you a few pictures of these, show you how beautiful and fascinating these animals are, then get into a little discussion about what's in the venom, because when we think of the venom, we think of it as this dangerous substance, but it turns out that biochemically it's extremely complex. We'll go over a few things we published recently, and then look at some of the recent work that we've been involved with the last 4 or 5 months in particular, and looking at culturing of breast cancer cells and the effects of some of these venom compounds on breast cancer cell proliferation. Hopefully I'll leave you then with the impression that this is a tremendous resource that we are tapping into. That is, natural products and natural products biochemistry is phenomenal. The diversity of compounds in there and the possibility for lead compounds for drug development is absolutely tremendous. I want to preface this by saying that I didn't do this by myself, and at UNC I've been very fortunate to have a number of both undergraduate students and graduate students, 3 of whom are named here, that have been absolutely outstanding in their work. We've also had the opportunity to collaborate with people from all over the world. I'm going to be on sabbatic leave this fall at the National University of Singapore doing work with a colleague that I've worked with there for a number of years. But as you can see from this list, we have people in Spain, a couple people here in the United States as well, actually some people at CU, and other spots around the world that are also interested in snake venoms and what's going on with those venoms. If we look at the faculty at UNC, I just want to put in a little plug here. We have a very, very diverse group of faculty, one of whom is in the back of the room here, Chandak Basu. And the expertise and research that we conduct ranges over a very wide range of aspects in the biological sciences. And so we don't have a very large group, but we have a very dynamic, very active, and very diverse group. Similarly, our students are tremendous. I've had 3 or 4 undergraduate students that have been co-authors, frequently primary authors, on published papers, and of course many graduate students as well. And so those of you who are involved in high school education, tell your students to talk to us. There are lots of opportunities here. Well, the first thing you might wonder is, why study venomous snakes? Why not? They're fascinating animals. They're very, very hazardous animals to people that are not familiar with how they react, how to handle them carefully, etc. But in fact, their venoms are one of the reasons why we are conducting this work. Their venoms are this tremendous resource of diverse compounds, primarily proteinaceous compounds, proteins, that have some very interesting activities and high degree of potential and actuality for development as tools or drugs. There are applications to disease that are fantastic. There are a number of different compounds that have been derived from venoms that are very central to our understanding of things like cancer metastatic activity, neurodegeneration. There's a recent drug developed from Gila monster venom that's shown great promise and great actual treatment of type 2 diabetes. Hypertension, one of the major drugs associated with treating hypertension, a major problem in this country, was in fact derived first from a Brazilian snake venom. And so there is just this tremendous resource in these otherwise dangerous compounds from these small animals. We're interested more recently in pursuing this end, that is drug development. Are some of these compounds useful directly as drugs for treating some of these disorders? Can we use them as lead compounds for understanding how these things work? Okay. Might be a little bit hard for you to see this in the back there, but in fact this is just a list of a variety of different toxins and where they came from and the various types of disorders that they in fact, are used to treat, as well as drugs that have, in fact, been developed from them. And this is just a small listing of some of the more lucrative and also very effective drugs. Exendin 4 is the one from the Gila monster, a venomous lizard that just recently has been on the market for the last year and a half or so to treat type 2 diabetes. Okay. Well, here's just kind of a rogues gallery of what we call frontfang snakes. Frontfang snakes have big teeth in the front that, like a hypodermic needle, deliver the venom very efficiently and very quickly to a victim. We actually then extract the venom from these animals, and these three are species that we have here at UNC. More recently, we've worked with venoms from this group of animals. They're so-called rearfang snakes. That doesn't mean they have fangs in the back end of the animal, but it means in the back of the mouth there are enlarged teeth. And in fact, those teeth conduct the venom from a specialized gland into the tissues. These snakes are much more difficult to work with because the amount that they produce is extremely tiny. But the advances in proteomics and genomics are now allowing us to work with almost microscopic amounts of material. And so it turns out that because these feed on all sorts of strange other animals, that there is some very interesting biochemicals in their venom. How do you get it? Well, it requires a bit of hands-on manipulation, and this is not the kind of thing you want to do at home. So rattlesnakes, it turns out, are actually very easy to extract. You just pick them up, squeeze their heads a little bit, and they express venom out of these fangs. And it's a little hard to see here, but there is venom collecting here. Fairly large quantity, takes about 5 minutes. The rearfang snakes, much more involved. They have teeth where the venom is expressed back here in the mouth. We anesthetize the snakes, give them a drug that stimulates production and secretion, and so it's a much more involved thing. And so this little animal, which is not hazardous to us, takes us about 10 times as long to extract as this, and we get about 1/10 as much material. On the other hand, most people haven't worked with that. It's novel compounds. It's a wonderful source. There are hundreds of these species worldwide, and so it's allowed us to do all sorts of interesting work. Sometimes we do extractions in the field. I prefer not to do this, but this was up in the highlands of Guerrero. We were there in 2005, and so we were extracting venom with a colleague from a university in Hidalgo. It's a rather interesting deal.